Hello, Sydney. It was a beautiful day in Sydney. Sunshine. I flew down from Melbourne. It was just raining and miserable all the time. So yeah, I'm actually from Sri Lanka, so I'm quite far from home. But yeah, my name is Isu Rajapaksha, and today we're talking about setting sail with Compose Multiplatform. Now, I kind of hid the title a little bit. We're actually going to be talking about how to navigate with Compose Multiplatform. Again, my name is Isu Rajapaksha. I'm a senior Android developer at Motorola Solutions. We make public safety applications. So we make apps for police officers in pretty much most of the policing agencies here in Australia. And hopefully they'll help keeping this community safe. That's the idea. All right, that's enough about me. Who do we have here today? Who are you? So who's doing Android development? Right, we got a few hands. Who's doing, supposed to press that. Who's using Jetpack Compose to do Android development? Few, maybe? Anyone here using Compose Multiplatform or have tried Compose Multiplatform? Got one hand going out. Who wants to use Compose Multiplatform? Yeah, got two hands. That's good. And who's here hasn't used either of these technologies and find themselves confused? Yeah, all right, that's good. So let's have a quick refresher. Now, I talked about Jetpack Compose. Jetpack Compose is Google's declarative UI toolkit that lets you write native UI code. You write something like this. This is Kotlin DSL, let's say, and you get some nice UI looking like that. It also has state management built right into it, so you can define or declare how your screen wants to be, and the UI will compose itself to achieve that desired state. That's where the name comes from. Compose Multiplatform is the sort of a fork of Jetpack Compose managed by the teams at JetBrains. Actually, it's from both Google and JetBrains in collaboration. Actually, both of these are sponsors for this event, coincidentally. And Jetpack Compose Multiplatform extends the Android's toolkit to bring native the UI support for iOS, desktop, and also the web. All right, so at this point, you might be asking, hey, what is this talk about? What am I going to be talking about? So let me set the scene for you guys. Jetpack Compose has its own first-party navigation solution, and this comes in the form of Android X navigation artifacts. But the problem is Compose Multiplatform doesn't have its own first-party solution. So that'll be what's on the agenda today. First, we're going to learn about all the different problems you're going to be solving using a navigation library. And then we're going to go shopping and see which of the libraries we like the most. Everyone's on board? Okay. Now that we know what's on the agenda, let's talk about what's not on the agenda, what we're not going to be talking about today. Number one, I'm going to not talk about architecture. And this is because I think personally, it doesn't matter. I think as a team, you need to agree upon which architecture you have to use and stick with it. It's not navigation library's responsibility to tell you what architecture to use. And instead, it should be your choice to make. And number two, we're not going to be talking about dependency injection. Again, it's the same reasoning. It's not the navigation library's responsibility to tell you what DI tool to use. You can use whatever you want and just stick with it as a team. The navigation library's responsibility is to complement that. All right, let's get on board. Now, I saw one person using traditional views. You can still use traditional views if you want to. And if you don't plan to use Jetpack Compose in the foreseeable future, that's fine. You're not forced to. No one's putting a gun next to your head. But I think you should still join in and experience this journey and sort of learn sort of cool things we're about to do with Jetpack Compose. And hopefully it'll help you appreciate how Jetpack Compose is letting you streamline some of the navigation logic. And even if you're not using Jetpack Compose, let's say if you're using something else to write your UI and navigation within your UI, I think you should still join in. And you can see all the crazy stuff we are doing at Jetpack Compose. All right. So we're about to board the ship. Now, we're going to take a look at 5 different navigation libraries. And these are those ones there. There's one thing called do it yourself. We're essentially going to try writing our own navigation library and see how it feels like. And we're then going to explore all the other solutions. All right, so let's start solving some of the problems. Now, one of the most common use cases for a navigation library is to a stack-based navigation solution. So to explain how this works, let's bring up an example where we have 3 screens. So in the ship, we have a gangway, which is like the bottom bit over there, and a deck, and a crow's nest on the top. So you can imagine the users are navigating from screen to screen. So when the user open your app, you land on the gangway screen. And this screen is technically called the root screen. If you see this terminology being used in some libraries, that's what they mean. And when the users press the up button or the up arrow button, they go to the next screen. One thing I want to point out here is that your previous screen is still in the backstack, but right now it's set to inactive or stopped. So here you can go further up and go on top of the stack, inactivating all the other configurations in the backstack. And when the users go back, what happens is you're expected to essentially see the previous screen. And at this point, the screen that users were previously on get destroyed. One thing to keep in mind is that users don't have to press a button on the screen to go back. Like for instance, on Android, for the longest time, we had a physical back button. Anyone remember that was the case, like actual back button on the device? And on the browser, for instance, you have a back button. In fact, in the browser, you can actually go forward as well. And sometimes you also you can type anything on that URL bar and go anywhere you want in the app. So navigation is not just restricted to screen buttons. All right, so let's take a look at some code. Now, this is going to be in Kotlin, so I'll try to explain as I go. So here I have an enum class to simply represent different screens the users can go to. And then I have a list of screens to manage the backstack. So right now, my backstack has only one screen, which is the gangway screen. So let's put that in the backstack. And so here I have a quick composable function that has 2 buttons. This is the one that gives you 2 different buttons you can click on. When you click on the next button, it'll go to the next screen. When you click on the back button, it'll go to the previous screen. Only thing you actually need to do here is to add your screen that you want to go to next onto the list of configurations. And to go back, you just need to remove that configuration from the list of configurations. And that's it. That's all the code you would need to implement that screen flow without any library implementation. That's about 42 lines of code, which is pretty good, I think. These screens are very static, so you will see why these matters in a bit later. So let's actually have a quick review while we're here. It's nice and simple, right? This only took 42 lines of code. I think it's self-explanatory, I guess. You don't need documentation to explain what that screen is doing. You don't need a library for this. It's just composed by itself. And the only problem with this approach is that these screens are not lifecycle aware. You'll see what this means in a bit later. But each of the screens that you saw, you wouldn't be able to know whether that screen has an idea of whether it's on the backstack or not. All right, so let's take a step back and see how we technically solve this using a library from Google. This is the Android X Navigation Compose libraries. Here, the idea is similar. You have a nav control on the top. This is where essentially you're defining the root screen, in this case, the island screen. And here we have a composable function that takes in a lambda where you put in your content. And to go forward, you just navigate to that screen. Here we're using a string. I'll talk more about that a bit later. In order to go back, you just pop the backstack. Again, that's it. There's 42 lines of, it's slightly more than 42 lines of code, but essentially it's the same as you would have done yourself, but you get extra stuff with it. Let's have a quick review. It's nice and simple, right? You don't need to learn something new. This is something that's available for you from the first part itself. And the only thing icky about it, personally, is the fact that you're using strings to represent like destinations, which is kind of icky. I don't know, you're kind of forfeiting some type safety in doing this, which we'll talk more about in a bit later. And it's not multi-platform yet. So that's something to keep an eye out. Let's talk about another library. And this case, I'm going to be talking about Decompose. Decompose is a library that's written on top of Compose. And here we have different, in this case, I have a seal class to show different destinations in my app. And the biggest thing about Decompose is everything is components. So every screen that you see in the screen hierarchy is going to be a component. Navigation is pretty straightforward. You create a stack navigation first, and then you create your own child stack. Once you do that, when you go to the UI part, you can define to go forward, you just push on that stack. And if you want to go backwards, you just pop the stack. And that's it. This was slightly more than 42 lines of code if you're keeping count. But let's have a quick review. It's a little verbose, like you had to write more code. But the cool thing is that UI can be completely pluggable. So if you don't want to use Jetpack Compose, you can still use traditional views with it, and it'll still work. And it is very customizable, so much so that I've written my own library on top of Decompose, and I call it Decompose Router. So let's take a look at that next. So with Decompose Router, the configurations are the same. You just need a seal hierarchy on the top. And instead of creating a component, you create a router. Router gives you a backstack for which you can push on top. If you want to go forward, you can push on top. If you want to go backwards, you pop the backstack. And we match the same use of lines of code. So essentially, this is similar to the DIY implementation. There's nothing foreign here. It's just the same API, if you will, like you would have written yourself otherwise. So let's have a quick review. Here's the DIY implementation side by side. You can see that it matches one-to-one. And it's nice and simple, if I say so myself. It's very familiar, right? You don't need to learn something new to implement that. And this is, most importantly, it's the best thing ever because I wrote it myself. I'm not biased at all. All right, so here's another library. It's called Voyager. It's a little different. That's why I sort of decided to keep this in. With Voyager, you essentially have a Navigator composable function on the top that you create. And you create your screens by extending a type hierarchy. And in order to go forward, you ask the Navigator to go forward. In order to go backwards, you have to hook into this local composition local to get a Navigator to go backwards. And that's it for Voyager. The only thing, let's have a quick review about this one. It's pretty easy to set up. It took me no time to set this up with Voyager. It's nice and simple because it's pretty much, it's not as complicated as the Decompose implementation. But the only thing is I don't really like about it is because you have to extend interface to create a screen. It's kind of going into the object-oriented pattern, which is not something Compose tend to do. And the newest kit in the block is called Circuit. This is from Slack. So if you're using Slack, they're using Circuit under the hood to implement navigation between the apps, on Android, I should say. Here, Slack has a lot of boilerplate. I don't know why. Let's quickly go through that. So in order to implement a screen, you need to have a state in using Circuit. So even if you don't need to put anything on the state, you still have to have a state. And in order to navigate from screen to screen, you have to implement a event model. In order to go forward, you can just ask the Navigator to go forward, and in order to go backwards, you can navigate to pop, and you can write your UI. This is something you would need either way, right? But the ugly thing here is that you have to write these presenter factories and UI factories to map the presenters with the UI, and that's a lot of code just for these 3 lines of code. These 3 screens. And we're not even done yet. So this is how the root screen looks like. And you can sort of judge by the font size there how much code you need to implement that simple screen flow. I don't know. It's not my test of code. So let's have a quick review. There's a unique idea of an event sync which avoids the coroutine machinery altogether, which is pretty unique. That's something like. But the problem is you're kind of locked into MVI. MVI is one of the architectural patterns. So if you don't want to do MVI, too bad you can't use circuit, you use something else. And it's too verbose. You kind of saw that. Like even if you don't need something, you still have to use it with circuit. I think the cool thing about circuit is it'll help you when you scale, but if your app is pretty small, just boilerplate. All right, that's the first problem. Let's take another problem. Another problem here we have a typical app we have is something called a tab/page navigation model. This is something you kind of saw in the previous presentation where they had like the top level navigation. And this is what you call a tab navigation model. Here we have, suppose you have a deck screen. So we have the middle deck, a back deck, and a front deck like that. So users can go to the left or the right. So in this navigation model, what the expectation is when you tap on the left button, the furthermost screen from the user gets destroyed. That's the expectation. So when the user come back to the middle screen, now that there's a slot open for this screen on the right here, at this point a new screen will be created and it'll stay in the back stack. When the user go to the right screen, it'll destroy the leftmost screen. And this is a typical behavior you would expect a navigation library to support. DIY solution looks pretty straightforward. Instead of managing a list, you just need to manage one page at a time, just what we want to do. And to go forward and backwards, we just swap that variable around. Android X navigation is a little more complicated. Instead of managing a stack, I mean, you just sort of essentially retrofitting a stack navigation to work as a page navigation model. And you can do this with a single top navigation option. In order to go to backwards or left or right, you just need to go to that page with a single top argument passed in. Decompose has this implementation built in. So instead of creating a child stack navigation model, you create a page navigation. And instead of child stack, you have to call child pages. And when you want to hoist your state, you just have to call pages composable function. Voyager has the same implementation. So instead of extending a screen interface, you have to extend a tab interface. The only thing key about here is that even if you're not planning to use a tab navigation, a tab UI component, you still need to provide the icon and the text. It's kind of, I don't know, feels icky to me. And that's how we would hoist your tab navigator into another screen. All right, the most important part of a navigation library is to be able to use both of these navigation modes and support a nested navigation hierarchy. So to explain how this works, let's bring back the two examples from the last time. We have a vertical hierarchy and also a horizontal hierarchy. You can navigate back and forth. So let's say we're on the bottom screen. You tap. So this is going to be our root screen. You tap on the arrow button. You go to the middle text screens. Here, if you press the left button, what expected is that you're supposed to go to the left screen. And at this point, if you press the up button, right, you can also escape the middle hierarchy and go to the outermost hierarchy. So by pressing the up arrow button, users will go up here, right? So at this point, I have a question for you guys. So what's the expectation of pressing the back button? Should you go back to the middle deck or should you go back to the back deck? So the way all of these libraries are implemented is that it goes back to whatever that was on the top of the stack when the users left that screen. So in this case, the user left from the back deck, so it'll go back to the back deck. This is the inbuilt behavior for all the libraries you've seen today. And at this point, I should point out that when you go back, the previous screen is destroyed. And this is also extends to the physical back button. So when the user press the physical back button, it'll first be consumed by the child screen first, and then passed on to the parent screens. So since we are inside of a nested hierarchy here, it'll get consumed by the child screen. In this case, it'll go back to the middle screen. And when you press back again, it'll go back to the bottom screen. All of these libraries works the same exact way, except for my DIY implementation, because that's something that doesn't have that implementation All right, so we can talk about animations. Who likes animations? Yeah. People on Twitter say they don't like animations. I mean, the mute button's right there, so you don't have to listen to that. Let's talk about animating and screen transitions. Now, let's bring back the same example. Now, if you, without animations, right, what would happen is that you'll just jump to the next screen, right? This is not only jarring, it's also kind of misleading, right? Because right now, users might be confused as to where you are in the navigation hierarchy, right? You wouldn't know without the like, let's actually bring back the animations. With animations, it gives you that subtle clues, or it helps fill that subconscious void, letting users know exactly where they are in the screen hierarchy. In the browser, you have this address bar that telling the user where exactly they are, so that's pretty good to know. But and sometimes you also have dedicated UI components like breadcrumbs telling users where exactly they are. But on like desktop, on iOS and phones with Android, we don't really have the luxury of screen space to show all those UI components. So we sort of rely on these navigations to tell exactly where the users are. There's a few different animations. You can slide in, slide container. These are coming from Compose by itself. But I think the cool thing here is that yeah, they actually come in pairs. So it's not just slide in and slide out. You also have like pairs of different animations. On Android specifically, we have something called predictive back, which is this nice API that lets you take a quick glimpse at the previous screen without actually going to it. It's like opening the door and seeing if anyone's on the other side, and just if you don't want to go there, you can just close the door behind. DIY solution, animations, you can do it yourself, right? This is nothing special. You can wrap your screen hierarchy in an animated content and just animate your hardest content. This is what Compose gives you from off the shelf. Android X Navigation Compose has this overloaded function. It's like 4 different functions for the 2 animations you want to put in. Decompose has its own navigation function as well. You can just pass in the compose animation into a stack animation, and you get to go. And Decompose also supports predictive back animations as well. Voyager has its own navigation implemented like that, which is weird because you have to wrap your composable navigator inside of, sorry, you have to wrap the transitions inside of the navigator. Something weird, I don't know. Circuit has something called decorators. It's a weird terminology. They're using decorator terminology in recycle views, so I don't know what it's doing here. Circuit also has support for predictive back animations. All right, so the next most important thing a navigation library gives you is the power to be able to scope instances to a given screen. Now, to explain how this works, I need to give you an example of 2 different screens. So imagine we have 2 screens to the user, a ship and enemy screen. On the left, we have a screen that has some state. So by state, what I mean is something happens on the screen. It can change over time. So in this case, we're firing a cannonball. It has it's making the sail on the enemy ship. It's firing into the sail of the enemy ship. All right, so let's talk about this screen where we have a root screen. Now, in this screen, what I'm going to do is I'm going to pass in an argument. And this argument is the initial number of cannonballs you start off with. Here, since the arguments that we pass on to a screen is a constant number, and the arguments by definition are constant, we can't change the argument once they are given to a screen. We need a way to keep count of the count of cannonballs in this screen. We need a way to keep count of that number of cannonballs. So what we're going to do is we're going to duplicate that number and keep it inside of the screen. So when the users fire off a cannonball, it'll decrease the number of count by 1. So on Android, something special happens. This is the very uniqueness of Android, if you will. If you rotate your device, right, what's actually happening is that your screen undergoes something called a configuration change. What this does is that it actually destroys your whole screen, which is counterintuitive, right? You don't expect that to happen just because I hold the device the wrong way. But that's what happens. That's a platform limitation. So when the users look at the screen, now your count goes back to 6, and users get lost where my extra cannonball come from. And this is why we need to move the state from the screen to some sort of an instance that can outlive your screen. So by keeping the state separate from your screen, even when you perform an action, it still can go down. But even when Android does its own weird thing, you wouldn't lose track of your number of cannonballs. The reason why we are sort of stapling that instance to your ship, or the reason why we are scoping that instance, is because we don't want to have these free-floating instances. So if the user goes to a different screen that has its own sort of instance in it, when the users come back from it, we want to get rid of both the screen and the instance, right? That's why we are sort of attaching that instance to that given screen. Android Navigation Compose library has this sort of built-in. You can call this view model injector function that lets you inject view models. And sort of in the previous slides, I've been avoiding the word view model, right? That's because a view model is just one of the architectures, but instances could be from different architectures. That's why I've been sort of being very careful with my wording. I've been calling it instances instead of view models because I want to be architecture agnostic. And if you have some other parameter that you need to inflate that view model, you can call that lambda method. In Decompose, all the components are by default scoped to the screens. So you don't even need to worry about this at all. All the components are instances that are scoped to the screen. Decompose router, since we don't have components in Decompose router, I have this convenient extension method. I called it remember on route to imply that this scope, this object that you're trying to remember, is going to be part of that route. All the libraries you've seen so far has this behavior built in, except for your DIY solution. So that's nice. All right, so this is a special slide for you guys. This is something no one actually seen yet. I just added it yesterday. So one of the most important aspects of a navigation library is to be able to restore state. It's essentially state management 101. So let's look at what this means. Let's take an example. Let's say you have a screen. The users come to your app, they navigate throughout the app, and they build up this navigation stack. They took like 20 minutes to get there, so this is a very precious piece of information to the user. And they get distracted and they open up a different app, TikTok or whatever. Right? And at this point, there's something lurking in the shadows, waiting to kill your app. And when the foreground app needs more memory, what happens is the system comes in, takes your ship, and destroys your ship or your app. This effectively deletes both the screens and also any state associated with your screens. So when the users come back to your app, actually, this is called the system initiated process death on Android. This is something very unique to Android. I think which is also technically true for iOS. So when the users come back to your app, they're going to land on the landing screen instead of where they were, which is considered bad UX. To test this, you can run an ADB command. You can use that command to list all the apps you have, and you can kill it individually. Or you can just use Android Studio's device inspector. So in order to solve this problem, what you have to do is to use a save state handle. So what a save state handle do is it's a way for the system. It's a way from the system that lets us save our objects for us. So when the app is about to die, what it'll do is it'll save everything that's important to the user. And when the users come back to the app, it's going to restore the state for you. One thing I want to point out here is that it's not going to restore the instances for you. That's something you'll have to do yourself, but it'll restore the screen configuration for you. Decompose router itself has this mechanism built in. So when you try to remember an instance, it'll give you this save state handle like that, which you can use to derive your initial state from. All the libraries except for Voyager. Voyager actually has an issue that prevents from this happening. but all the other libraries has this behavior built in, which is pretty nice. And that's it. We are at the end. Today, we learned about page navigation models. We learned about stack navigation models and what's the difference between the two. We learned about animations and nested hierarchies, arguments passing, and we also learned about scoping. And we also looked at how this is done differently in different implementations. So we looked at the navigation Android library, Decompose, Voyager, and your circuit from Slack. Thanks for coming, and thanks Motorola for empowering me. And thanks Akardi, he's the library author from Decompose, for going through my talk and reviewing it. And finally, you have a QR code. I just put this part of the presentation. I'm not sure if that actually works or not, so let me know if it doesn't. But that's the QR code for the repo up there. Thank you. Questions?
Questions. Remember, the best question gets a prize.
No questions.
Nobody wants a shiny coffee mug. Yeah.
Is there a coincidence that in circuit the flag is Australian?
Oh yeah, that's. So I was looking for so I'm using Keynote to animate my slides, and when I search plug on Keynote, it gives you that Australian plug by default for whatever reason. I'm assuming when you are in elsewhere, it'll just give you the localized version of that icon.
That's my question.
That's not their logo.
No, that's not their logo. None of this. So the thing is, none of the libraries. This is a dev thing. None of the libraries have their own icon. So I have to be very creative in coming up with my own icons.
They should hire me.
They should hire a designer probably.
Your own. Oh, when you did your own, which we all agree actually is the best. What did you name it? Did you give it a really cool name? Can I suggest a name?
Sure, go for it.
Can I suggest Candy for the previous capital, or Serendip for the previous name of the country you come from?
Yes. So funny thing. Actually, the name of the library was actually called K-Router when I first started off. K, because in Kotlin, when people come up with libraries, they have to prefix with the K. That's a thing we do in Kotlin. I don't know why we're doing it, but I almost called it K-Router, but ended up just settling with Decompose router because I'm sort of extending the Decompose library to create my own router library. But Candy is a good name too. Maybe I should.
Candy with the K.
Yeah, Candy with the K. That's how actually it's spelled. So works out.
Yeah. No.
Yeah. One more question?
There was another hand raised. I saw. There's.
I was just curious about Circuit and how recently Slack implemented that. I've noticed a number of navigation bugs in its recent release.
So one of the Android 14, when the Android 14 implementation came around, the back button doesn't work anymore. So when you try to use the platform back button, it just closes the app. Pretty sure that's a bug. If not, there's some serious design problems there. But yeah, there's a lot of navigation issues. But I don't think it's necessarily just because of Circuit. It just could be because different feature teams in Slack. I actually met Zach. He's the sort of the person running Slack. There's a lot of feature teams, and all of them are not using Circuit yet. So there's some disparity with features there.
And just on that back button thing, it happened with me today on a non-composed traditional view navigation using the intents and everything. When I added that manifest flag for invoking the new callback, it would just take me out of the activity or the fragment instead of my backpress handler. So I'm fairly certain it's a platform bug and not necessarily a navigation bug.
Yeah,
so
it could
hopefully gets fixed in the next build.
Hopefully Android 15 comes around and they make that the default.
We have to wait 1 year now.
Yeah, it's like
okay.
Yeah, maybe next year.